Now what is the heat engine? You might have heard about. Yes, so we know that heat engine which we used in the vehicles. So in that the fuel has been burned. Again that burned fuel will produce a lot of heat. Now that heat we are going to utilize. So just with the help of which the piston has been moved in and out of that cylinder, and which is again connected to that your crankshaft, and which is just connected to your wheel. Yeah, so the wheel starts to rotate. So this heat engine is a device which converts continuously the heat energy into mechanical energy in a cyclic process. So this is the source is there, the sink and the working substance. So there is a hot reservoir or the source at T1, so from which you have to take out the heat, just convert some amount of heat into work done, that is a heat engine, and some reject some part of the heat to the surrounding. So that is how we used to work on that your heat engine for this case. So this Q1 is equals to heat absorbed from the source. Again the work done is Q1 minus Q2. Again the rejected heat to that cold reservoir which is at low temperature, that is maintained at T2. So the source, that is a large amount of heat at temperature T1. Sink, it is nothing but again the heat which is at lower temperature, again the working substance. Yeah, so which will do some work. So that what we say over here. So what is the efficiency of heat engine? Obviously which is output upon input. So simple, we can say that. So in case of your output you can say which is work done. So this work done upon input is Q1, and the work done you can write it down, that is a Q1 minus Q2, that is a work done upon Q1. So this is how we can calculate the efficiency of your heat engine. So this is how we can calculate the efficiency of heat engine, which is 1 minus Q2 upon Q1 for this particular case over here. So you might have heard the different types of heat engine. One is the external combustion engine, another is the internal combustion engine. So basically there are few limitations for your this first law of thermodynamics. It doesn't indicate the direction of transfer of heat. Again, it doesn't tell anything about the condition under which the heat can be converted into mechanical work. Again, it doesn't indicate the extent to which the heat energy can be converted into the mechanical work continuously over here for this particular case. Now we will start with that second law of thermodynamics. There are many processes in which the energy is conserved and yet they are never observed, that is observed. Yeah, so this is how what we can say with this second law of thermodynamics. Yeah, so there are different statements for this your second law of thermodynamics. So that we will see for this case over here. So this is the hot reservoir of your heat which is at higher temperature. Some part of the heat has been taken out, so the work has been done on that, and again it is just rejected to that cold reservoir over here. So definitely the efficiency of the engine, it can't be 100%. Yeah, so this is what we can say the Kelvin Planck statement. Yeah, it is impossible to construct an engine which will produce no effect other than you're extracting the heat from the reservoir and performing an equivalent amount of work. So definitely some part of the heat that is just going to be, you have to just, for example, definitely you just reject. Yeah, so the reservoir, just you are taking Q amount of heat, you have to do some work. Yeah, again over here also reservoir, just take Q amount of work and just that work is done. Yeah, so this is how we can just do. This is the two things which are possible for this particular case, for this your Kelvin Planck statement. So this is clausius statement. It is impossible for a self-acting machine, yeah, unaided by any external agency, so to transfer heat from a body to another at higher temperature. Yeah, so this is how we can say that. So the TH has to be greater than TL. So the heat pump, so the work is 0, which is impossible. Yeah, so definitely this is how the clausius statements tell over here. So just taking the Q amount of heat from this hot reservoir, and then just some part of the heat again just you can say reject to this cold reservoir over here.